Right. Okay, take it away. I'm going to make sure that your screens are available.
Okay. Hi, everyone. My name is Subhrajyoti Sen, and today I'll be talking to you about where exactly do your app's state go. I am a mobile developer on the Tickertape team, and Tickertape is a suite of tools that lets Indian investors make better decisions. So if you are an Indian investor, please do give it a try. Okay. First thing first, this talk is not about how to do state management, and I won't be prescribing ways of how you should be handling state in your app. This talk is mostly about life cycles and certain changes and variations that have happened over time and how that can lead to different cases, which a lot of apps forget to account for. And it's something that we all really should be considering in our apps. Okay. When we first think of handling life cycles, there is one thing most of us would have done in our early days when we started writing apps: locking the app to portrait mode. It's something we tried it as a quick hack, and it's something I tried last year on a project as well. But is this enough? Definitely no. And it's a big no. But there must be reasons for this, right? So the first thing would be dark themes. It's something that we all love on apps. MultiWindow, and the third would be process debt. I'll be discussing each of them in detail and also the cases you come across. First off, dark themes. They were introduced in Android 10. They can be toggled in two ways, either by using the system's theme switcher or by using App Compact inside your app to be able to switch between themes or make it align to the system theme. Now, why exactly is this important? So whenever you toggle the theme using either of the two ways, it triggers a UI mode configuration change. And this in turn starts recreating all of the started activities. So you can see that even though initially we thought locking the app to portrait would prevent our activities from being recreated, or at least handle most of it, that's not entirely true. Here, the activities is getting recreated from something that's not even inside the app. Now, if you want to handle it, the first thing you should be doing is try to implement a dark mode. But for some reason, if you are not, you should at least start try toggling it while your app is open and see if it breaks, and start actually doing proper state restoration and handling life cycles properly. But what if you don't really want to do that? You can mention the config changes as UI mode in your app's manifest. And what this will do is it will invoke on configuration change in your activity instead of recreating the activities. Now, this shouldn't be used as a way of escaping state restoration and handling cases. It was rather designed to allow you the flexibility of handling extra cases that you might want to do while toggling apps. But it's like a temporary hack. Next up is multi-window. For those of us who haven't used multi-window before, it lets you use multiple apps on your phone screen at the same time. So in this image, you can see that on top we have the Tickertape Android app, and at the bottom we have Play Store. Now, why exactly is multi-window an important case? First of all, it was introduced in Android N. So no matter what app you're building, you most likely will come across this, but because your app is most likely working on Android end. It did not alter activity life cycles, but it did have a slight change on how different lifecycle methods were called. And what one key takeaway from handling multi-window should be that you can't completely depend on your on pause and on resume. So consider you are developing a media player app, or rather a video player, for example. You would normally pause the video on pause and resume it on resume, and that works, but not in case of multi-window. So in multi-window, you can see that there are two apps open, but both of them won't be on the resume state. One of them will be on the on started state, and one of them will be on resumed. The one that you're actively interacting with that has focus, that is the one that has its resume state, and the other one is in the started state. Sorry, it's on the pause state. And so in this case, you should move your handling logic to also, handling your video play lifecycle logic to your on stop and on start. And then you can check if the app is in multi-window mode and then handle cases accordingly. One very interesting case is that, remember how we locked screen orientation in our activity initially? Once the user puts your app in multi-window mode, it doesn't matter. Android will completely ignore what screen orientation you have given it. So our initial assumption that our app won't be switch between portrait and landscape mode is completely false when it comes to multi-window mode. And that is why you should, if you plan that your user might use your app in multi-window, you should start giving good focus on how exactly you handle your portrait and landscape modes, your different resources, dimensions. And it's very important to remember that portrait orientation doesn't necessarily mean vertical device. This becomes especially important in case of multi-window. So what this means is that just because your app is, your device is in a vertical orientation, it doesn't mean that your app will be in its portrait orientation. Portrait orientation just means that your Windows height is more than your Windows width. And if the user resizes the window in which your app is located in the multi-window mode, your app can change between landscape and portrait mode. And that's something you really need to consider. Now, if you don't want your app to be used in multi-window mode, maybe your app needs all that real estate, or it's something that is specifically meant to be used as a single app and not in conjunction with another app, you can opt out of it by adding the resizable activity and setting it to false in your Android manifest. Coming to the third case, process it. It's something a lot of us tend to not account for while developing our apps, and even I hadn't. And that can sometimes lead to very weird cases in your app, and it depends on the devices as well. So on some devices, the OEMs do optimizations that let the OS kill the apps more frequently, and hence process that is a case that should be handled better on a lot of apps. You wouldn't really want your user to go very deep in your app's navigation, put it to the background, and 10 minutes later, when the user comes back to the app, the user sees that he has to start from scratch again. So that's a very important case. It happens when your device is running low on memory and the OS kills your app to free up memory. Again, like I mentioned, on certain OEMs, this is more aggressive. On other OEMs, it's a more reliable. It happens if your app is in a stop or pause state. It won't happen that you are actually actively using the app and Android just kills it. It's only when it's in the background and the user has switched to a different app that this will happen. and you can't really work around it. Like we saw in case of dark theme and multi-window, you had ways of working around them as a temporary measure while you actually fix things at a fundamental level. In process death, you can't really work around it, so you have to account for it. There are a couple of ways you can test for process death. One is you can go to develop options, apps, and then background limit. And you can choose your background limit to be no background processes. Now, whenever your app goes into the background and comes into the foreground again, it will be recreated. It's a very handy way of checking if your app actually handles process death properly, or any app for that matter. So you can play around with some of your favorite apps and see if they handle it properly or not. Another pretty handy way is put your app in the background and run adb shell am kill with the package name. One thing you have to remember while running this command is what I mentioned, that your app has to be in the background. So if your app is open in the foreground and you run this command, it won't have any effect. So you put it in the background first and then run this command, and then just open the app again and you'll be able to test for your process death. Now, something that recently a lot of apps have started using is view model. Now, view models will persist across your activity recreation, but out of the box, it won't persist process death. So a lot of us start using view models as a short way, or like an easy way of handling life cycle changes and like restoring a state. And we think that it handles everything. But process death is something it does not handle out of the box. For that, Google released saved state handle, and it lets you save and restore state. It kind of works similarly how you would use a bundle on store instance state, on save instance state, and on restore instance state in your activities. It's something similar to that. How exactly do you use your view model, save state handle in view models? So while creating a view model, you have to pass in an instance of save state VM factory to the view model provider. Now the view model will get it as a constructor parameter, the save state handle, and this is a map. So it's normally how you would interact with the bundle, that you would store values and get values. Similarly, that's what you do here as well. And whenever your process is recreated, the same save state handle will be provided back to your view model. So if you're using view models and want to support process, want to account for process death, after the talk, just go and start using save state handle in your view models. Okay, this is custom views. This is one case that a lot of us who make custom views tend to forget. And this applies to even default views also. So what we tend to neglect while writing custom views is the view state restoration mechanism. We do create our custom views and the function as expected. And if you look at a lot of custom views that you get as libraries, many of them tend to miss out the part about state storing and restoration. If you go take a look at the source code of most of the default views, you will see that they do handle state restoration. So some considerations, and these hold true for normal views as well, that each individual view can choose to ignore to save its state, or it's its own responsibility to save its specific state. And you have to give your views an ID for your state restoration mechanism to work. The way this works is whenever a view is recreated, Android will go through the entire view hierarchy, and only for those views that have an ID set, it will call the corresponding methods to let you store and restore state. So if you have not mentioned an ID, you won't really be able to save and restore state. And the way I came across this was a few hours of debugging initially, where I tried showing someone an example who was new to Android. I tried showing him an example that if you have an edit text and you enter text, rotate the device, you will lose on the text that you have input. And that is one of the most common use cases I think we have seen when we started developing for Android. But in my case, the text just remained. And I was very puzzled because I know as a fact that on rotation, it's supposed to go away. That's what I would say most of the tutorial videos have shown us. After digging a bit deeper, I realized that since I had set views as like a habit, I had set views on those edit text, and that's the reason they were actually restoring the state. Now, to be able to store your view state, you have to implement this class called base saved state, and that is true for all views and custom views that want to do state restoration. So this uses a parserable, and it has a pretty simple interface. Once you extend it, you can have instance variables in it, which store the data corresponding to your state. It's mostly a verbose class, like you just have to implement. You don't really have a way out of it. Once you have written the basic methods, there's also a requirement that you need to have this static member called creator, and it has to implement the parserable.create interface. So it is a hardbound requirement, and you cannot bypass it. So all it does is it creates a saved state from a parcel, and that is all you need to do to start supporting state restoration. Now, this is like a plugin mechanism. So you have written these classes. Now comes the part where you treat it like a normal activity of Fragment. So on an activity of Fragment, you would be calling on save instance state. Similarly here, but here what you do is first you let the parent view group of your view save its state. Now you use that to create an instance of your implementation of base save state, which is saved state here. And there you store all the data relevant to your view, as in your view state, and return it. So it's just a parserable, and it's equivalent to what we do for activities and fragments. Similarly, on restore instance state, you get the state, you ask your parent to start restoring its state, and from the parserable, you just pick up the values you want. And after that, you might want to call invalidate, some other measuring functions, depending on what your view does. Okay. Big question about testing. Once you have done all of these, you would see that a lot of these were manual. So if you had to like test out your, if it's if your activity handles the state restoration properly on activity recreation, a lot of it was whatever I described was like a manual process. So I'm sure there will be a lot of doubts regarding testing as well. So to test your activity and fragment recreation, it can be done with Espresso. And internally, a lot of libraries would be using Espresso to do it. And to handle things like activity recreation, you could write a custom rule that recreates the activity and gives you access to the new activity. But it gets easier to test these with the Android X testing libraries that we have. And I'll show you exactly how it makes it easy for you to test things. So I'll be taking the example of fragments in this case. And you can include this artifact, the fragment testing artifact from Android X. So coming to testing your fragment recreation, you would start it out as a normal UI test. The way you start launching a fragment is you have to create a scenario. And the way you do this is first you launch it. You launch your fragment inside a container, because normally you would use something like a frame layout or a fragment container view. So this handles that. You don't really need to actually create an activity and then add a fragment. Like, you don't really have to do all that manual process. You can just launch your fragment in a container. And the best part is you can provide arguments, specific themes, and a lot of other things by using this launch in container method, launch fragment in container. So the launch fragment container method returns to you a scenario. Now, if you see launch fragment in container takes just the fragment class name. You don't really create a fragment on your own. And this is a good reminder to always pass arguments to your fragment and not use different constructors or get a setter methods to actually set different values of that are to be used in the fragment. Please use arguments. Now, once you have the scenario, you can perform different actions that you want. Like if you want to mutate your state to go to a particular scenario, you can do that. Then you can just call recreate on your scenario, and this will emulate fragment recreation. And after that, you can test different events to verify that your app actually handled the state restoration properly. So one of the benefits that we get with the Anodex testing library was easy recreation, but there's also good benefits of how you handle life cycles. So normally, if you're testing out your apps manually, it's a bit tricky to go to the different lifecycle methods manually. I mean, you could do that, but then you would need cases where like some other app opens up when you're using the app. It's not that straightforward, right? And you wouldn't really want to do it manually over and over again. So Android Accessing Library gives you a way to drive your fragment to different states. It's similar to what we saw for recreation. You start out by launching the fragment in a container, get a scenario, and then you can move your fragment to different lifecycle stages. So here you can move your fragment to the created state, and you can easily switch between the states, and you can really test out that your app behaves as expected in the different lifecycle methods. It comes in very handy, especially if you do different things on different lifecycle methods. So I've seen a lot of apps where all of, I would say, the object allocation and everything happens on view created in case of fragments. But you ideally should be using appropriate lifecycle methods for initializing different objects, interacting with views. And once you start implementing things like that, move to state becomes really handy to make sure that at each stage, your app is behaving as expected. And that's it for the talk. Thank you for attending, and please do try out dark themes and multi-windows to make sure that your apps behave as expected, at least on your devices.
Thank you so much. Well, we are a little bit over in terms of time, so I think we'll just have the questions on Slack. So people, if you have questions, please go ahead and type it in Slack, and then we'll get them answered that way. Because I do want to make sure, we have some break time so that people can grab a drink and things like that. But thank you so much.
Thank you very much.
Yeah.